Okay, if we want to do exponents on the calculator, 3 to the 7th, that is not the same thing as 3 times 7. Not 3 times 7. So it is 3 to the 7th, which, remember, that means that you're taking that 3 multiplied by itself, and you have 7 of those 3s. So 1, 2, 3, 4, 5, 6, 7. All 7 of them. Now, I don't want to write those out every time, and I don't want to sit and count and multiply each one of them separately. Sometimes we just have to calculate, and we have to do it quickly. So I want to know that this is what it means, but I also want to know how to get a result very quickly on the calculator. So we're going to use our to the button. And I know, right? So it's 3. So I typed in 3, and now I need my to the button. And it's this little caret on my calculator. Some calculators are going to have a y to the x button. And I've even seen one with an x to the y button. And some will have the to the button. So one of those buttons, 3 to the, so I'll do the to the next, and it just shows it as a caret. And then 7. So 3 to the 7th. And then enter, so it tells me it's 2,187. And that is my result, 3 to the 7th. So I have another one here. Go ahead and give it a try, and then we can compare answers. Two to the 5th, I got 32. And the neat thing about this calculator, not like I'm trying to make you go out and buy it, but I do like it a lot, is that it shows you what it used to calculate here, and then you can see the result. So if you got a different answer than me, you can go back here and say, oh, I put times instead of to the, or I didn't use a 2, I accidentally typed a 3, whatever. That way you can kind of see what you've done a little bit better than some of the other calculators that I've used. Here we have a fraction raised to a power. That is equivalent to 1 to the 5th over 3 to the 5th, just in case you were wondering. But I can do the whole thing on my calculator using my fractions, 1/3. I pushed enter. Now it has that sitting in as my answer, and then I'll just do my to the button, and it's going to use that 1/3 that was the previous answer and take it to the 5th power, and then push enter, and it's going to leave it as a fraction for me. Sometimes we want that. So 1/3 raised to the 1/5 power is going to be 1/243. And we can see that we would probably get that as well. 1 to the 5th is going to give you 1. And then 3 to the 5th, that's where we're getting the 243. So we could do that as separately, numerator and denominator, but the calculator does it really nicely, so we want to know how to use that too, because the more we can let the calculator do, the less little errors we make, the more accurate our math work will be. Now this one's a little bit tricky. And that is because if you look at this one, it's very similar, but one has parentheses and the other doesn't. The one without the parentheses means that you really are taking -1 times 6 to the 4th power. And when I think about that, 6 to the 4th power is going to give me, like, I don't know, 720 something. And that number will be converted into a negative because of this -1 here. This one, on the other hand, is -6 times -6 times -6 times -6, which means that my negatives are going to multiply here and give a positive. Those two will multiply and give a positive. So when I take a negative number to a 4th power, the negatives are going to go away, and I'm just going to have a positive result. So one of these gives me a negative, one of them gives me a positive, and it all depends on where the parentheses are. Now let's see what the calculator does if I type it in exactly the way it's showing here. So I have to use this button down here to get my negative. You might also, on your calculator, have a plus negative button like that. And that's the same thing as what I'm about to use. So the negative, and then 6 to the 4th. So it looks the same pretty much as what I have on my paper, and let's try it. We expect, remember, a negative number and somewhere around 700 something. Well, okay, maybe 1200. But it is working correctly. When I typed it in exactly as it's showing here, I did get negative 1296. And just because I'm curious, I'll do 6 to the 4th and see that it does come to 1296. So I was off in my head on my calculation there. Let's look at this next one and type it in exactly as it's showing, because I have parentheses on my calculator, so I can use those. Parentheses, negative 6 parentheses, and then to the 4th. Okay, that matches exactly how it's showing on my paper. So I expect, remember, for it to be a positive 1296. So let's see if we get that. We do. Okay, so the long story here is that you have to either think about what's going to happen to the negative. Is it being duplicated for every base that we're multiplying by, or is it just a single negative out front, which is going to force my answer to be negative? And if you're not sure which way it's going to work, you can think about where the parentheses are, and then also make sure you type it into the calculator using the parentheses as they're showing. Now I'm hoping that your calculator came up with these exact answers when you typed in your problem the same way that it's showing on the paper. If not, you will have to adjust to make sure it comes out right. All right, let's look at some roots. These are like square roots. In fact, this one is a square root. And when you do a square root, you are trying to find the number that you multiply by itself to give you the radicand, or this number under the radical sign. So this funny looking thing is the radical, this number here is the radicand, and this is the index. Now if you have an index that's not a 2, you may not be as familiar with that, but what you're looking for is a number that when cubed, in this case, gives you 8. And so we're thinking about what times what, or what times itself gives you 8. And I'm hoping you're thinking, well, isn't that 2? Because it is 2. So what happens is 2 cubed and the cube root of this undo each other because they are exact opposite operations. And so all we have left is a 2. So when I work this by hand, I know it should come to a 2, but I want to show you how to do it with your calculator. So I'm looking for the nth root. Here is a square root, which is not the case, not what I'm using, but I have the nth root, and that's going to let me put that 3 for my index. So I'll do 3 nth root, see how that looks, and then 8, and I should get a 2, and there's my 2. Okay, so that one actually worked. So we always try with something simple that we can kind of reason out and figure out if it's correct, and check if we're doing the calculator right. So later, if I'm trying to remember how to do my cubed root and I can't get it to work, I should try something easy, like I know the cube root of 8 is 2, so I put it in the order I think it should work, and then see if I get the 2. And if I do, then that's the order I should use. If not, switch your order around. If you use, I like this calculator a lot because it's really inexpensive. It's the TI-30XA, but the only problem with this calculator is that everything's backwards and you can't see what you're typing in as you do it. So if I'm going to do if I'm going to do a cube root on this calculator, first I have to find it. There it is. Right, this one has a y to the x for the exponent button. If I want to do the cube root, I think I have to do 8 cube root 3 equals. Yeah, so you have to kind of do it backwards. So that's why I keep talking about the order and what order you want to use. So this calculator works the direction you think it should. And then that other one that I was showing you doesn't, it's backwards. So here we'd like to do this, we would say the fourth root of 625. So let's try it on the calculator. Fourth root 625. And I get 5. That's nice. Okay, try this one and see what happens. So I need the third root, so third root of 8 squared. So I'll do 8 to the second power. If this gives me 4, then I did something wrong. So let's try it one more time. So we'll do the third root, and then I'm going to put parentheses 8 squared, like that, so that it's going to square the 8 first and then do the cube root. And there I get 4 still. So 8 squared is 64. Okay, so it does make sense. But I don't know which order it's doing it. It doesn't matter, does it? Okay. So cut out all that, the mess. Let me start that one over again. Okay, so let's give this one a try. When you work this problem, we have a property that says that this is equal to the cube root of 8 squared. It's the same as if we do the cube root of 8 squared. It doesn't matter if I put the squared underneath the radical or outside the radical. So because of that, it doesn't matter how I type it in. So I can do the third root of 8 squared, and I get 4. The third root of a negative 64. Third root negative 64, and I get a negative 4. And if I do the square root of a negative 64, now I can use this other button for the square root. So I can do square root negative 64. And that gives me a domain error. So what that means is that this is not a real number. And when we say real number in this case, we're talking about the set of real numbers. It is a complex number, and if you remember from Algebra 2 in high school, that complex numbers are a result of the negative under a square root. And so we can think of it as the square root of negative 1 times the square root of 64. And when we do that, the square root of a negative 1 is I, and the square root of 64 is 8. So our result is 8i, or if we're restricting ourselves to just real numbers, which our calculator does, then we would say not a real number. So it depends on what we're doing with the numbers and whether we want our real results only or if we want complex results. So this one is a complex number.